Hello?
Goodbye.
I'm sick.
It's such a hard words on those slides.
I'm losing my voice.
You're losing my English.
You've been losing yours.
When did you ever have it?
Oh, I know. Sorry. I forgot. I have a phantom memory.
Okay, let's start.
Or not?
It's easy.
Okay.
Okay.
That's what he says every time.
No, I feel like it's gonna be easy.
Okay. If it's easy, I'll give you 5 minutes. Come
Blah.
on. What? You just
Oh
like
my
look at
God.
this. Done.
Blah.
Blah. Okay.
Blah blah.
Okay, algebra.
Yeah.
Algebra.
I don't know what.
Get your y's to one side, get your x's to the other.
Q.
So it's
I gave you guys the proofs in the notes to make it a little bit easier, so you can go back and look at it. But I'm giving you the short, sweet, and very, because I know you have short attention spans because as you're reaching for your phone right now, trying to check your Instagram.
Who are you talking to?
X is on the
Exactly.
Uh-huh.
I'm sorry, but you messed up this time.
X is
Nobody
on the
wants to
right.
know.
Y is on the
left.
Left.
okay.
Maybe dy-
Algebra.
Oh.
dy
No.
over y squared equals-
Okay, so now I'm going to multiply by dx to get the dx over here, okay?
Okay.
And then I'm going to divide both sides by y squared to get my y's over there, right?
Yeah.
So when I'm done, I should have 1 over y squared dy is equal to
Wait,
3x
dx.
dx, right?
Okay, what would you use?
Yes?
Are you okay? I think they're dying.
Did I lose you already?
No.
At least
I
now.
got confused. Wait.
Okay, so I multiplied by dx, right?
Yeah, I got that part.
So that goes away, right?
Yeah.
So divide by y squared,
Okay, that makes sense. Okay, got it.
okay, and it's gone from over there.
Okay.
No, your y squared became x.
Now, for right here on my left side, this is a dy, this is a dx.
Uh-huh.
So now, since it says something dy, what does it normally happen? What type of process do we do when we see a dy in my function? What am I doing when I see a dy or a dx in my function?
Find antiderivative.
Antiderivative, right? Or the integral. Let's do the integral.
Yeah.
Because I want to get rid of my dy. I want to get rid of my dx. So to undo that, I'm going to take the antiderivative or integration. So let's do that. So here,
Okay.
okay, so
First
now,
one is gonna be,
so right here I move my y squared up. So that becomes y to the -2, right?
yeah, so it's gonna be 1 over
Negative 1 over,
3,
nope. Remember, if this is going to be y to the,
2.
ah,
No, over 1,
watch. If I move it up, it's y to the -2, right? Integration, I add 1
and divide.
and then divide by that number, right? So if I add 1, it becomes a -1, right?
Yeah.
And divide by -1 makes the whole thing negative, right?
Yeah.
So I'm just going to put it back down. So it's going to be, that's -1 over y, right? Okay, good. So I took care of that. Equals. Now let's integrate the right side.
3 over 2x squared.
3x squared over 2 plus c.
Yeah.
Now, there's a plus c on the left-hand side also.
Oh, but we can just cancel it because it's going to be.
We're not going to cancel it. We're just going to add 1 because if I put plus c here, if I put plus c here and plus c here, and I move it to the other side,
Yeah.
would that cancel out the c's?
Yeah.
I don't want to cancel out the c's.
Why?
Because this is some c, this is some other c. They're
Why?
two different c's.
So where's the c on the left?
They're two different c's. So this would be like plus c1, and this would be plus c2.
Oh, you just-
They're two different c's. But if I add, they're constants, right?
Mhm.
If I add this and this, does it just give me some constant anyway?
Yeah.
So it's kind of like 2 times the constant is just still a constant. Does that make sense? So instead of writing it in two separate ones, I am just going to write one single C that's eventually going to come up. So, because I only add it to the right-hand side. But theoretically, it's on the left, it's on the right, and then I moved it over to here, and I combined it, so it's a C plus a C is going to give me some other C. But it's still some constant, okay? Does that make sense? So this right here is my equation that I have right here. So this is a general solution. Okay, this is going to be the general solution for this. Does that make sense? Does that make sense? So I stop right there and say, hey, this is a general solution. I'm done with that part. All right, so now I'm going to go to the next one. So I have my general solution, negative 1 over y equals
3x squared over 2.
When x equals y equals what? 2. How many variables are in this general solution? 3. There's an x, there's a y, and there's a c, right? But if you know the x and the y, I can find the third one, right? So let's do that. So it's going to be negative 1 over 2 equals 3 over 2, right? And that's going to give me 1 squared, which is 1, plus c. I did some fast math here. Are you guys okay?
Yes.
Move it over to the other side. So it's going to be negative 1/2 minus 3 over 2 equals c, which is negative 4 over 2, right? Negative 4 over 2, which is negative 2, is equal to my c. Now I can put it back in. So this is a particular solution. This is a particular solution. So when I have a particular solution, I have an x, I have a y, and I know the c value. Okay, so let's take a look. So since I have this right here, let's go ahead and plug it in. So my particular solution is negative 1 over y equals 3x squared over 2 minus 2. There's my particular solution. But now let's make this, make it so I don't have any fractions. Let's clean up all the fractions and then move and set everything equal to 0. Okay, that's another way of writing this answer. So no fractions and set it equal to 0. All right, what's going to be the common denominator? So I'm going to get rid of fractions. Y and 2. So the common denominator is going to be 2y, right? So multiply everything by 2y. So as I do this, y's cancel, so I'm left with negative 2 equals. So as I distribute this way, 2's cancel, so I'm left with 3y, and this one right here, minus 4y. And I said I want to set it equal to what? 0. So that means that I need to add 2 to both sides, right? So 0 equals 3x squared y minus 4y and plus 2. What?
Nothing.
Are we okay?
Yeah.
Not bad, right?
It's quite a long book.
So this is my, okay, this is my particular solution. So general solution and particular solution. General solution has a c in it. Particular solution, you solve for c. Use slope field represents solution of first order differential equation. Blah, it's all there. Using slope field represent the solution of this. Using slope field to represent what we have here. Okay.
So it's gonna be.
Now, I'm going to show you. So let's separate this out. So I got a little bit of rules to go along with this. So my y is on the right hand side, right? There's no really an x, is there? Okay, good. So if I were to separate this, right here, what would it look like?
dy over y.
So 1 over y dy equals
D.
just dx. Is there an x there?
Like after integration.
There. Okay, but that's not what I'm trying to get at. I'm trying to get at right here. There is no x here, right?
Right.
So one of my rules for this, so I do not. Now, since there is no x at this point right here, I could say that since there's no x, all points same on the x-axis. And I'm going to show you what that's going to look like. Okay? So, let's take a look. Let's go a little bit further with this. So, integrate.
I mean
L and y equals
x plus
x plus c. Right? Yes? Okay, good. So this right here, now e both sides, right? So this is going to be e. Ah, crap. No, I was looking on the right hand side. Sorry. It's just y. Y equals e to the x, right? So I'm going to show you guys what this is. So e to the x plus c, right? Say yes.
Yep.
Okay, because I'm eing both sides of that. But what does it mean, a plus sign, when I have a plus sign in my exponent? So let's look. I'm going to go like, so x3 times x2. What does that give me? X to the fifth, doesn't it? X to the fifth. So I'm going to show you guys. So this is basically saying x to the 3 plus 2, right? Okay, so it means I have the same base. I have the same base. So I could actually rewrite it like that. So if I have the 3 plus 2, can I go back and rewrite it like this? Okay, I can. So now since it's x plus c, I could rewrite that as e to the x times e to the c. But now, is c some constant?
Yeah.
C is some constant. So if I'm multiplying a c, is it still a constant?
Yeah.
So it's going to be some constant number. If I'm adding c's, it's still just going to be some constant, right? No matter on what I'm doing to that c, it's still going to be some constant. So that's the reason why this is going to change into y equals some c e to the x. Yes? Because I see you guys writing right now, so I don't want to hurry you too much. All right, so I'm using this information right here. Now, we're going to do a okay, so I have to go back and I have to remember the settings. So I'm going to show you guys, but I got to pull it up on my calculator. Documents, graph, and I want to change this No, it's not that one. Prime is 1 over y. There we go. All right, so let me show you what this means right here. So I was able to get it. So let's change my window, and I'm gonna do my window smaller. Let's go -2 to 2. Actually, let's go 3. Because I just remembered I have to use 2 in that one. 3. This one's going to be -3. This is going to be 3. And change this to be 1. Change this to be 1. All right, and I'm going to show you guys why. So hopefully you'll come back to this video and watch it again. Okay, right here, I'm making this smaller. So, since I do not know the C value, I'm going to have some graph here. Some graph here that's going to fit this. So just depending on whatever my C value is, I'm going to have a different constant for each one of these. Now, let me explain what I just did. This is called a slope field. It gives me all the possibilities of the equation at a specific point. Okay? Or did I lose you? Because y'all just...
Yeah, wait.
All possibilities.
So
All possibilities.
For any seed.
For any seed. So now,
Oh.
how about this? Let's pick a number. Okay? I'm going to pick a number somewhere on here to try to make it a little bit easier. I'm going to pick right here. I'm going to pick 0, 2. Okay? So I'm going to pick 0, 2. So let's now zero, 2. So now I have this is my solution for this now. Here's the graph of my line. If you notice, it starts over here, and then it follows all these slopes as it's going. All the way this here. Does that make sense? So it follows this right here. So I have a particular solution, which is right here, for what I have.
So what are the other dots?
This is just one solution. All these other, so if I pick another one, yeah, so all the different solutions for my C values.
How do we know which one is right?
They're all going to be right.
Yeah, but
They're all going to be right.
so this is just in general.
Yes, that's why it's a slope field. You're never going to have to actually do all of them.
I mean,
As biggest you'll ever have to do is like a 2x2. To left, to up, to right, to bottom.
Still.
Yes.
the dots. That's what I meant. Like,
Oh, the dots.
The ones all the way to the left,
Yeah,
they're like
those, like,
spread
what
out
are
everywhere.
those?
That's where it doesn't exist.
It's just like, okay, I'm done here.
So if I do the math on it, it's not going to exist.
My brain right now.
Okay, but I was just confused why a little bit.
Yes, it's still, let me hit enter. These other weird dots right here, it's, because at this point, it's not going to exist. It gets weird. But if you notice these ones right here, starting at 2, it's going to be fine. Now, look at all the slopes. This is what I was talking about. There was no x value, was there? There was no x value in my differential equation. So now look at all the way across, all my x values right here, all of them have the same slope. Reading left to right, they're all same slopes, right?
Yeah.
Same slopes, left to right. So that means that there is no x value. So if there's no y value, what do you think it's going to look like?
Straight up and down.
Up and down, it's going to have the same pattern. It's going to have the same pattern up and down if there would be no y value. Does that make sense? So, make sure you write it in your notes how to actually get here. So I'm going to doc B right now, so you guys can see this again. So doc B, go to my graph. Now, what am I entering? Menu. Okay, graph entry. Yes, differential equation. I know you're writing that down because it's going to be so important later. Now, if you notice it says y1. So when I enter my variable has to have a y1 in it. So if you notice this little tick mark right there, that means that's the derivative. That means I have a dy dx, right? So when I start off this thing and I want to do the antiderivative, I'm starting off with a dy dx, right? Since I'm starting with that, that means I have a first derivative, and then I want to find the solution, so I have to have an antiderivative to get that solution. So that means I plug in the control divide 1 over, it's not just y, it's y1. So that means it's the same as this. Because it's possible to have a second one too. Y1, because this is y1 right here.
No, why is 1 over?
Why is there one on top? He's asking.
Oh,
Our antiderivative is not.
what was my problem again? Oh my goodness, did I? Just y. Dang it. Okay. Oh, okay. So same thing. Oh man, I graphed the wrong one. But anyway, same reason. So this is just going to be y1. There we go. Okay, so different slopes. So if you notice going left to right, they're all the same. And so now, let's try a particular solution for this one. All right, let's change my window real quick. Window, -3, 3. -3, 3. Let's see if auto does it. Nope, auto puts too many in there. Yes, I want 1. Because otherwise it breaks it up into too many smaller parts. Okay, so now, no, because if you notice right here, instead of having right here, I had a bunch of little ticks. Now I only go 1, 2, 3. All right, let's try a particular solution now. I want my particular solution, go back up here. So I'm going to put the point. What was it, 0, 2? Yeah. 0, 2 is my x and y. You guys getting stuff done?
Yeah.
Yeah.
There it goes. So there's my particular solution for this one right here. I could do the same thing at any point in which that it does exist. So there's my one particular solution. I could have picked a point down here, and then it would follow the same thing going in the other side, right? So we have this right here. Use subfield, draw some graph, family solution for this one right here. So I'm going to show you guys how to graph this tomorrow. Not tomorrow, Thursday.
By hand.
Yes, by hand. All right, don't forget, like, share, and subscribe.